We're going to find the derivative using the limit process, and this is the equation that we're going to use, or this is the formula we're going to use, not the equation, but the formula. So the first thing we need to do is figure out what f of x plus h is. Now, many people, many college professors and different people are going to use delta x instead of h. Just throwing that out there just in case you see that. So instead of h, they'll use delta x. It represents the change in x. We're not going to go there, not right now. That's okay. So everywhere we see an x, we're going to put x plus h in its place. So we have x plus h, and it is squared. The whole quantity is squared, and then x plus h, we'll put it in parentheses for no reason at all. And we have that. Okay. Quick foiling. We're going to write it twice and foil it. We're going to have x plus h minus 3. We'll have x plus h and x plus h. First, outside, inside, that was hx and hx. That makes 2 of them. Last, plus x plus h minus 3. Okay. Let's start plugging these things into this formula. Let's talk about this formula for just a minute, though. What it really means is this. We would love to be able to put a 0 into this formula and figure out what the value would be, but we can't divide by 0. Also, I want you to realize that this is just a very fancy formula for slope. This is y2 minus y1 over, check this out, this is cool, x2 minus x1, and the x's would have canceled and it leaves you with an h on the bottom anyway. So it works out to be the same thing. So it's just a fancy formula for slope that leads us to finding a general form for a derivative. Okay, so we're going to plug these into that formula and simplify it. We'll switch colors here. We're going to go to green. So looking at that, plug that in first. So the limit as h approaches 0 of x squared plus 2, pardon my smudge, hx plus h squared, I don't know my h's and my x's apart, plus x plus h minus 3 minus the original function, which is right here, staring you in the face, x squared plus x minus 3. Be careful, what did I forget? Nothing, because I remembered it. I wanted to see if you remembered. There we go. All divided by h. Let me state the obvious. We'd love to plug a 0 in, but we can't. I know I just said that, but just wanted to say it again. At this point, something happens that always happens with polynomials. There are other creative ways of doing it if it's not a polynomial, but there. Those cancel. Those are going to cancel, and those are going to cancel because we were subtracting them anyway. There's some other fantastic stuff that's just about to happen. We'll do it in this step as well. We can cancel an h with every single term on the top. This h is going to cancel with that h. It's going to cancel with one of those h's, and it's going to cancel with this one, and h divided by h is 1. Okay, so we'll come over here and we'll rewrite this, having simplified it as much as we know how. So the limit as h approaches 0 of, well, our denominator's gone, so we have just one big polynomial here, 2x plus h plus 1. At this point, it's perfectly legal to plug in 0 for h, so it's equal to 2x plus 0 plus 1. Well, obviously, 2x plus 1. 2x plus 1 is our derivative. Now, we knew that anyway, but this is where the shortcut comes from. We could have looked at this and told you what the derivative was, but we would have never known this originally had we not gone through this process.